Okay, so we're continuing with factoring. We're going to factor trinomials of the form ax squared plus bx plus c. So what that means is that when we're going to factor, the number in front of x squared is not a 1. It's a number bigger than 1, okay? So sometimes you might have a polynomial with a number in front of x squared. But once we look at the GCF, we might factor it out. So in this case, I wrote an example 2x squared plus 4x plus 6. They have a 2 in common. GCF is 2. So once I factor that out, the trinomial I have, now it does have a 1 in front of it. Okay, so I'm going to be looking at those that after I factor the GCF, or if there isn't a GCF to factor, I still have a number bigger than 1 in front of my x squared. That's that a term, okay? So we're looking at those type of polynomials, or three-term polynomials, where we have a number bigger than 1 in front of x squared. So the method that I'm going to be using is called the AC method for factoring, in case you guys want to look that up. So let's go ahead and practice. So the first example, example 5a, it's 2x squared plus 11x plus 15. So the way that works is you look at the coefficient of the first term here, which is a 2, the constant term here, which is a positive 15, and you multiply those. So 2 times 15 is 30. So I'm going to look for factors of 30. So two numbers that multiply to give me 30, that is going to add up to that middle term of positive 11. So let's see, I know 2 and 15 is 30. So when I add those, I get 17, not 11. Okay, let's try another pair. I know 3 and 10 is 30. When I add those, I get 13. I need an 11. That's not the pair. 5 times 6 is 30. When I add those, 5 plus 6 is 11, so that works. So those are the numbers that I'm going to use. So once I find those numbers, what I do is I rewrite my trinomial. It's actually going to become now a polynomial with 4 terms. So I'm not going to change my first or last terms, so let's keep those. So I write 2x squared, and I keep my 15, my last term, plus 15. But I use these two numbers that I found to rewrite this middle term, 11x. So 5x and 6x, those are the coefficients that I write, 5 and 6, with the x, give me the 11x, right? So look at this new polynomial that I wrote. 2x squared plus 5x plus 6x, that's 11x plus 15. So that's the same as my original polynomial. I just rewrote it now with 4 terms. Now I do it like that so that now I can factor, and now I'm going to factor this by grouping method, okay? So now that it has 4 terms, I'm going to apply the method of factor by grouping. So again, that involves you group the first 2 and the last 2 terms. Now I can rearrange the terms if I wanted to group different pairs together, but it works to group the first 2 and the last 2. As long as they have something in common, you can factor out. So when I look at 2x squared plus 5x, what is their greatest common factor? And it's an x. So I divide everything in this first set by x. 2x squared divided by x is 2x. 5x divided by x is 5. So I write that. Okay, then I look at my second set, 6x and 15. They have a 3 in common. So 6x divided by 3 is 2x. 15 divided by 3 is 5. And what do you notice? We should see here that they have the binomial 2x plus 5 in common. So that's the next step. I take the 2x plus 5, factor it out. So when I divide this whole first set by 2x plus 5, I just have the x left. So that's x. And this second set over here divided by 2x plus 5 leaves the 3 plus 3. So that is the factorization for that one right there. Okay, let's do another example, part B. Okay, it works the same. First step, we should always check, is there a GCF to factor out amongst these 3 terms? 8x squared minus 22x plus 5. And no, there is not. So again, because the coefficient or the number in front of x squared is bigger than 1, I have to take that number, multiply it by the constant at the end. 8 times 5 is 40. Okay, So now I'm looking for factors of 40 that add up to this middle term, a negative 22. So I know 2 and 20 is 40, but if I'm going to add them to get a negative, they actually both have to be negative. So negative times a negative is a positive. So negative 2 and negative 20 is the positive 40. And when I add two negatives, negative 2 plus negative 20, I do stay with the negative. I get the negative 22. So I actually found that pair in my first try, right? So just like before, I'm not going to change my first term. So I leave my first term, 8x squared. I'm not going to change my last term. I leave that plus 5. But I replace the middle term with these two numbers that I found, negative 2x and negative 20. And again, like we mentioned before, we're going to factor by grouping at this point because now I have 4 terms in my polynomial. Okay, factor by grouping. So the first 2 terms get grouped, and like I mentioned before, if you wanted to rearrange them, you could. And the next 2 terms get grouped. It's a negative 20. Okay, so careful with that sign right there. So what do 8x squared and 2x have in common? 2x. When I divide both of these terms by 2x, 8x squared divided by 2x gives me 4x. Minus that 2x divided by 2x will be a 1, so minus 1. From the next set, negative 20x and 5, they have a 5 in common. But again, like we've mentioned before, when the first term is a negative, factor out a negative. So I'm going to divide this by negative 5. So negative 20x divided by negative 5 is a 4x. And 5 divided by negative 5 changes the sign, minus 1. And like before, you see the common binomial that they have, 4x minus 1. So that's now what gets factored out as the GCF, 4x minus 1. When I divide this first set by that 4x minus 1, it's going to leave me the 2x. And when I divide this next set by the 4x minus 1, it's going to leave me the minus 5. So that is the factored form for this one. Okay, we have a few more examples. Moving on to example 6. Okay, again, I want to factor 2x squared plus x minus 15. They don't have a GCF, so I move on. I'm going to multiply because the number in front of x squared is bigger than 1. I'm going to multiply these two numbers, 2 and negative 15. Gives me negative 30. So I'm going to find factors of negative 30 that add up to the coefficient of this middle term, which is a 1. So if I multiply to get a negative, that means that the two numbers have to have opposite signs. So for example, I know 2 and 15 give me 30, but one of them has to be a negative so that when I multiply, I get a negative. So negative 2 and 15 gives me negative 30, but if I add, I do not get the one that I need in front. So let's try another pair. I know 3 and 10 gives me 30, but I need a negative, so one of these has to be a negative. Negative 3 and 10. When I add those, I get 7, not a 1. Okay, well, 3 and negative 10 also multiply to give me negative 30. When I add those, I get negative 7. That doesn't work. What about 5 and 6? One of them has to be negative. Negative 5 times 6 is negative 30. Negative 5 plus 6 is the one that I need. So this is the set that I'm going to use. So let me go back and rewrite my polynomial. Don't change the first term. 2x squared stays. Don't change the last term, negative 15 or minus 15. But this middle term, I'm going to get a 1x by using the negative 5 and 6. So negative 5x plus 6x. Okay, continuing on, like we said, now I do factor by grouping, so let me group the first two and the next two. 2x squared minus 5x have just an x in common. When I divide 2x squared by x, I get 2x. When I divide minus 5x by x, I get the minus 5. 6x and 15 have a 3 in common, so that's what gets factored out. 6x divided by 3 is 2x, and 15 divided by 3 is 5, so that's minus 5. And at this point, you should see They have the 2x minus 5 in common. So that's what I pull out, 2x minus 5. From the first set, dividing by 2x minus 5 will leave me an x. From the second set, dividing by 2x minus 5 will leave me a 3x plus 3. So students sometimes ask if the order matters. Do I have to write 2x minus 5 first, or can it be the next one? And it doesn't. So I can rewrite this as x plus 3, 2x minus 5 as well. What does matter and what is important is what's inside the parentheses. The signs matter as well. So it has to be a plus 3, a minus 5. It has to be an x and the 2x. The x has to be with the 3, the 2x with the minus 5. So all of that matters, but you can choose to write the two factors in a different order as well. Okay. One more example of this form, again, because these three terms, 3x squared plus 10x minus 8, don't have a GCF. So I look at the number in front of x squared, 3, and the constant negative 8. Multiply those, I get negative 24. So what are factors of a negative 24? They give me a positive 10. So again, because it's a negative number, when I multiply, I need to multiply two different signs. So I know 2 and 12 give me 24, but one of them has to be a negative to get a negative 24. So negative 2 times 12 gives me negative 24. When I add, I do get a positive 10. So I got that one in my first try. That's the set that I will use to rewrite this polynomial. So again, 3x squared stays, don't change the first term. Negative 8 stays, don't change the last term. These numbers, negative 2 and 12, are what replace that middle term. So negative 2x and 12x, again, because negative 2x and 12 add up to give me the 10. Okay, so I'm just rewriting that trinomial. So again, like I've mentioned right here, it's factor by grouping because I have 4 terms. Okay, so you're going to be really good at factoring by grouping with your 4 terms. Okay, first 2 terms are grouped, next 2 terms are grouped. 3x squared minus 2x have an x in common. 3x squared, when that divides by x, it leaves me 3x. 2x, when that divides by x, leaves me 2. That's what I get there. 12x minus 8, those two numbers have a 4 in common. So that's the GCF I pull out there. 12x divided by 4 is 3x, and the 8 divided by 4 is 2 minus 2. And just like with all the others, you should see when you're doing the factoring by grouping, you'll end up with that common binomial factor. So just like the other ones, now that's our GCF. So that 3x minus 2 is what I pull out. Dividing that first set by 3x minus 2 is going to leave me the x. Dividing that next set by 3x minus 2 leaves the 4. So this is the factorization for this one. Now you can always check whenever you're factoring by distributing. So if you wanted to check any of these answers, then you can go ahead and FOIL them out, and it should give you the original answer. So now you should be very familiar with all of the factoring methods, and just with a little more practice, you'll be really good at this.